Welcome to this tutorial on starting the Mirage F1 from cold, including the necessary alignment of your navigation systems. We will go through an expedited startup procedure, how to fire the engine correctly, the operation of the PCN Navigation Control Panel present in the Mirage F1 EE, how to perform the required INS alignment in the F1 EE and the various methods you can use, the necessary systems to get you off the ground, and a quick sweep of the cockpit to check for readiness. Hello fellow virtual aviators, we are back in the alacritous Mirage F1 and today we'll be looking at procedures for getting her started from cold. It's a fine day at Vatsiani Air Base near Tbilisi, Georgia. The sun has just risen and we've just had our breakfast, and we're going to fire up this beautiful dart of an aircraft. As usual, this will be an expedited cold start procedure of my own preference rather than the full from the manual checklist. We may sprinkle in a few wholly unnecessary steps to add a bit of flavour, but in general this procedure will be enough to get the Mirage F1 ready for action from a fresh spawn. Many of the switches required during startup are already in the correct positions when the aircraft spawns, so some of the real-world essential steps will be omitted. The starting procedures for the F1CE and the F1EE are very similar. The most obvious difference is the alignment of the F1EE's INS inertial navigation system, which is absent from the F1CE. So first, we'll learn the basics of the F1CE startup before looking at how to perform the same in the F1EE. So first things first, we'll ensure the parking brake is engaged with this lever here, ensuring that it is pulled out to the out position. The Mirage F1 fresh spawns with wheel chocks, but the crew will automatically remove these when we add electrical power to the aircraft, so we don't need to request this from the crew chief. It would be at this point that I would normally ask the crew to rearm and refuel the Mirage F1 according to the mission of the day, using the usual mission resources menu. However, for the purposes of today's tutorial, we will be starting up with a clean aircraft. Let's close the canopy by reaching up and engaging the handle to drag it shut. Seal the cockpit by placing the canopy lock lever in the forward lock position. Next, we will apply electrical power to the aircraft with the battery switch placed in the upward on position, and double check that the switches for the two alternators are in the upward on position likewise. In case of emergency, should the engine firing malfunction, it is usual to turn on the warning horn at this stage by placing this switch, labelled avertisseur sonore, meaning warning sound or buzzer, in the forward on position. The horn will sound. Silence the horn test by pressing the master warning button on the front dash. We are now ready to fire up the engine, which must be done in a particular and deliberate fashion. Before doing so, we need to ensure that the throttle lever is in the full cut-off position, which is fully aft, as you can see here. If it is not, for example as shown here, it is essential we move the throttle back to idle and to press the throttle cut-off idle switch to move it to cut-off. We will now provide fuel and prepare to ignite the engine. Open the main fuel cock, labelled coupe feu, by placing the switch into the left open position and close the guard over it. Switch on both the left and right fuel pumps, with the switches labelled pump BPG and BPD by placing them into the left on position. Set the ignition selector switch to either the left or middle position for the left or right igniter respectively. In the real Mirage F1, it is usual procedure to alternate which igniter is used for each startup to minimise wear. Lift the engine start button cover which will automatically knock the starter fuel pump switch to the left on position. This should extinguish the engine fuel pressure warning light, BP or basse pression, low pressure, after 2 seconds. We are now ready to fire the engine. Depress the engine start button for 1 second and monitor the engine RPM gauge. You must act quickly. When the engine RPM is between 300 and 600 revolutions per minute, press the throttle cutoff switch to advance the throttle to the idle position. A quick way of doing this is to simply click the throttle. So depress the starter button for 1 second, release, monitor the RPM, and when we get to 300, which is there, advance to idle. The engine should continue to spool up and will settle at approximately 2,900 revolutions per minute. The jet pipe temperature gauge should also be less than 700 degrees Celsius when the engine is self-regulating. With engine RPM steady, we can now close the engine start button cover. A quick glance at the warning light panel should show that most of the warnings and cautions in the top 3 rows have extinguished, indicating that we now have oil pressure, hydraulic pressure, and alternating current. Provide AC power to the emergency AC electrical buses by lowering the inverter selector switch down to the rearm position before allowing it to return to the center. The warning light SEC, or secours, emergency will extinguish. Reset the flight control system servos by pressing the servo reset button here marked servo. This should extinguish the 5 caution lights on the bottom row of the warning light panel, leaving only CAP and ANEMO illuminated at this stage. If necessary, retrim the aircraft to neutral using the trim hat on the HOTAS and the rudder trim control on the left console, ensuring that the trim tab indicators are aligned. We can now switch on the remainder of our systems. What I tend to do is sweep along the left console, then sweep along the right console, then across the front dash and its periphery, and finish with the lower center area. So, starting with the left console, we'll turn on our taxi light by placing the landing light control switch into the fully forward position. We'll turn on our green radio by placing its mode selector into the PAL position. We'll also switch on our red radio at the rear of the console by placing its mode selector into the M position. Adjust the radio volumes as desired. We'll set our slats and flaps to fully deployed by placing this lever in the fully aft position. And we'll ensure that the high lift device mode switch, labelled Hypers or Volets Hyper Sustentetur or high lift flaps, is set to the normal position, and the combat flap lever on the throttle is closed. Moving over to the right console, we'll first switch on various systems and sensors. From the left to right, the backup attitude indicator labelled Horizon Secours, meaning emergency horizon. The electro pump. The pitot heater labelled ANEMO, standing for Réchauffage Anémométroncidence, meaning anemometer contact heating. The radar warning receiver. And, if desired, the searchlight labelled Phare de Police, literally the police headlight. Whilst here, we can set our exterior lights, placing these 2 switches into the up position. Next, we will prepare our navigation systems. Set the gyroscopic reference system control selector to the GM, or gyromagnetic position, and set the emergency gyromagnetic compass switch to the forward M position. Your navigation gyros will take no more than 2 minutes to align. During this time, do not change the setting on the gyroscopic reference system control selector. Whilst the gyro alignment is happening, we will continue setting up our other systems. Set the radar to standby by placing the radar operation mode switch in the central standby position. Switch on the sight head by placing the sight selector switch into the central M position. Switch on the fuel dipper by placing the fuel dipper switch into the forward M position. Set the air conditioning master valve control switch to the forward M position and ensure that the temperature control and temperature mode switch are both set to automatic. If you haven't already done so, you can set the interior lighting as desired. On the front dash, confirm the failure flag on the spherical ADI has disappeared. Uncage and tune the backup attitude indicator with the adjustment knob. Set the operating mode of the IDN navigation indicator as desired with this slider. Tune the barometric pressure as desired on the primary slaved altimeter and the backup altimeter using the adjustment knobs. This will be determined by your flight profile as to whether you tune to QNH or QFE. Set your countermeasure system as desired. On the lower center area, engage the high sensitivity nose wheel steering by pushing this button in. If required, set the IFF transponder's master mode by placing its mode selector to the standby or N normal positions. Turn on the required IFF mode and set your transponder squawk code with the wheel selectors as required. Remove the ejector seat safety pin by pulling it forward. We are now ready to taxi, but first what we want to do is a sweep of the cockpit to ensure everything looks correct. So just go over every panel and make sure everything is set the way that you want it. In particular, we should have no illuminated lights on the warning light panel, and the master warning light, the combat flaps light, the NWS warning light, and the air brakes light are all extinguished. The startup procedure I use for the Mirage F1 EE is pretty much the same, save for the addition of the inertial navigation system alignment. This is performed in the middle of the procedure after I have switched on the gyroscopic reference system, as the gyro compass can provide information to the INS when it is aligning to help speed up the process. We also need to ascertain what kind of alignment we require, whether this is a full alignment or one of the two options for a faster alignment. So the initial startup procedure is exactly the same. We'll apply the brake and we'll close the canopy. Switch on battery electric power, switch on the warning horn and cancel it. We'll now fire up the engine. The fuel cock switch is in the same place, but the remaining switches are now moved to the rear of the console. So the two pumps and the igniter. Engine start. Monitor the engine RPM till 300. And when it's between 300 and 600, move the throttle forward to idle. On the emergency AC buses and reset the flight control servos. Retrim as required, which we need to do so here. Taxi light. Our two radios, which are now together. Switch those on. And our slats and flaps to fully aft. Check the high lift devices switch and the combat flaps. Internal lighting panel is now on the left console, so now would be a good time to deal with that. Switch on our remaining systems. Switch on our exterior lights. Switch the gyroscopic reference system control selector to gyromagnetic position and set the emergency gyromagnetic compass. We now need to align our inertial navigation system, our INS, which is the most sophisticated navigation system in the Mirage F1, at least for its time. If you are unfamiliar with INS, essentially it is a system that can measure changes in an aircraft's position in all three Cartesian directions, latitude, longitude and altitude, as well as changes in an aircraft's velocity and orientation, without the need for an external reference such as a beacon. It does this by using a series of sensitive but not perfect gyroscopes and accelerometers, which provide inputs to a computer, and through the magic of integral calculus it then calculates how the aircraft has moved. Because it can tell how the aircraft has moved and is moving, it can tell where the aircraft is, which is obviously essential for navigation. However, the Mirage needs a reference or datum point from which to measure these changes, so that the information has some meaning. In other words, it needs to know where it started from, its initial position. And this we need to program into the INS computer. This is done on the PCN, the Poste de Commande Navigation, or the Navigation Control Panel. We have a data display which shows various navigation parameters in alphanumerical form, a row of status lights to show what the PCN is doing, a mode selector to provide power and to tell the PCN how we want it to behave, a parameter selector to choose what to display, a typical alphanumeric keypad together with some function buttons, a waypoint selector wheel, and a panel light switch. Let's power up the system by moving the PCN mode selector to VEI, or standby, and ensure that PP is selected on the PCN parameter selector. This is present position. In other words, where the INS thinks the Mirage F1 currently is. Now, before moving the aircraft, we need to check to see if this is correct, which we can do on the F10 map. So let's bring up the map. We'll find our own aircraft and click on it. The bottom left, we will be able to see then the actual specific location of our aircraft, and we need to note that down. So we can see that we are north by 41 degrees, 37.541 decimal minutes, and east by 045 degrees, 02.112 decimal minutes. And we can see that the present position is incorrect, it doesn't match, so we need to update and align the aircraft. It is standard practice to align the aircraft against the information stored in waypoint 1. So we'll ensure that this is selected on the waypoint wheel, and then move the PCN parameter selector to select POS. This shows the selected waypoint's position information, latitude on the left and longitude on the right. We now need to update this according to the aircraft's true position. So we'll update the latitude first using the keypad, select N for north, and then type 41375, which is our position rounded to 1 decimal place on the minutes, the limit of the display. When correctly inputted, press Insert to save it. We'll do the same for the longitude. Select E for East, and then type 045021. If you make a mistake, press Clear and start again. Again, press Insert to save the correct information. We now need to tell the INS system to align the aircraft according to the information stored in waypoint 1. Set the PCN selector to ALN, Alignment Normal, and then press the asterisk button to commence the alignment process. Change the parameter selector to STS, Status, to monitor the progress of the alignment. The full alignment process takes approximately 8 minutes. During this time, the alignment status light will flash. The counter on the display will count up to 999, at which point the full precision alignment is complete. You will need to be patient. This does take some time. At approximately 7:20, the alignment status light will become steady. This indicates that the course alignment is now complete, and it has entered the fine precision alignment stage. When the full precision alignment is complete at 999, the green Prêt or ready light will illuminate. The Mirage F1 is now ready for INS navigation. Place the PCN mode selector to Nav and the PCN parameter selector back to PP. You can see that our present position now matches the true position of our aircraft. Whilst the alignment is happening, you don't need to sit there like a lemon waiting for it to reach 999. You can continue setting up the remainder of your systems. So let's switch on our radar to standby, whose switch is now on the front dash. Turn on the sight head and the fuel dipper, and set the environmental controls. Tune and set your instruments on the front dash as normal. We have a different IDN navigation indicator in the Mirage F1 EE, but we'll select a mode for it anyway. Set our barometric pressures. And set up our countermeasures. Turn on high sensitivity nose wheel steering, whose switches move slightly further down. Set the IFF transponder if you require it. And arm the ejection seat by removing the safety pin. Whilst you are doing all that, it is easy to overlook the completion of the INS alignment, so don't forget to switch to navigation mode once it is done, and switch the parameter switch to PP. Complete your cockpit sweep and necessary checks as standard, and we're just about ready to go. An alternative to the 8-minute full normal alignment is the rapid alignment, which takes approximately 3.5 minutes. This is used in scramble situations. The required initial position coordinates are inserted in the same way. However, the alignment is performed by setting the PCN mode selector to ALR, Alignment Rapid. As before, press the asterisk button to start the alignment. Monitor status with STS on the PCN parameter selector. Once the counter is beyond 720, the pre-ready light will illuminate, and we can cease the alignment process at this stage by switching to nav. Our present position is now correct, but the systems will not be as accurate, and you can expect a higher INS drift if using ALR. So do choose wisely. The third method is by a stored heading alignment. If the aircraft has not moved since it was last powered down, the INS system will have saved the present position. If you are playing on a multiplayer server, it is likely that your aircraft will spawn already aligned. This is a simulation of the situation described, or of yourself or the crew chief having already aligned the aircraft previously and it not moving on the tarmac since. In this situation, the Mirage knows exactly where it is, so we can perform a stored heading alignment, a significantly quicker alignment option taking approximately 90 seconds. When we power up the PCN to standby, the present position coordinates are correct for your aircraft's location, then we can use this method. Set the PCN mode selector to ALCM, Alignement sur cap mémorisé, or Stored Heading Alignment. Commence the alignment with the asterisk button as normal, and monitor the alignment status. At 999, our pre-ready light will illuminate, so we can switch over to navigation, and we can see that our present position coordinates are correct. We then just need to complete the rest of the startup procedures and get ready to taxi. Well, as ever, I hope that was useful for you. The fact that you can trace the development from the similarities between the F1 and the Mirage 2000C is fascinating, and I hope you are looking forward to getting her in the air. If you are wondering, alacritas means quick and lively. With heartfelt gratitude to my patrons, Jan11 and Lakota21, your support will always be thankfully received and faithfully applied. Feel free to do the usual thing, like, subscribe, comment and share, but until next time, virtual aviators, keep on rocking, keep on flying. This is Reiver saying last call.